Three questions with the right angle triangles. Here's a word problem that is saying two tracking stations A and B measure the height of a rocket to be 4 kilometers. The angles of elevations of the rockets are found, or the rocket are found to be 72 degrees and 55 degrees. So basically 72 degrees from here and 55 degrees from here. How far apart are the stations A and B? So what they want you to find this here. So this is what we call indirect question. You won't be able to do this in one step. So the first thing you want to do with this one, you have two triangles at 90 degrees right here, both of them. So if you look at this triangle right here and start working with this, so I'm going to call this portion right here from here to here, I'm going to call it X. And from here to here, I'm going to call it Y. And so if you find X and then find Y and add them up, that will give me the total distance in here on, or how far they're apart. So I'm going to find X first. So to find X, I'm working with the angle 72. Now, with respect to angle 72, I'm given the opposite and I'm looking for the adjacent. So, and this is the hypotenuse, is the longest side, and it's the hypotenuse is always opposite to the right angle. We have to use TOA because TOA, tangent, is opposite over adjacent. So if we go tan 72 degrees equals the opposite, which is 4 kilometers, over which is adjacent, which is X. When the unknown is on the bottom, what I advise you to do is just cross multiply exchange kind of thing. So I call it cross exchange. So the X goes to where tan 72 is, and the tan 72 goes where the X is. And therefore X equals 4 over tan 72, which equals so this would equal 1.3. So X is 1.3. Now let's find Y. So Y here, we're using this triangle right here with the 55 degrees. So if you look at Y to 55 degrees, 4 kilometers is still the opposite, and Y is the adjacent. So this is the adjacent right here. So again, we're going to use tan. So I'm going to go tan equals the opposite, which is 4 kilometers, over the adjacent, which is Y. And this is the same thing because the unknown is on the bottom. So just cross exchange. So you get Y equals 4 over tan 55 degrees, which equals 2.8. So therefore, this between AB, which is B and this, and AB and this, so the whole length here would be 1.3 plus 2.8, which equals 4.1 kilometers. Next question. So the next question is asking me, there's a tree besides the house. It's 14 meters away from the house. And if this tree falls, would it hit the house? So you have 4 choices. The top of the tree will just touch the side of the house. The tree will not hit the house or the side of the house. The tree will hit the side of the house. There's not enough information. Okay, so what they need to find is basically the height of the tree. So just give me 1 second here. So what we're finding is the height of the tree. So to find the height of the tree, I definitely know from here to there, it's 9 meters long. Why? Because the height of the house from here to here is 9 meters. And so up to here is 9 meters. Now this is a 90-degree angle. So what I want to do, I want to find out what's the rest of the tree here, what's the height of that. So to find out what the height of that is, I have the angle 25. What I'm looking for is x, which is the opposite. And I have 14, the adjacent. So again, this is a tan function. So I go tan 25 equals x over 14. Now it's one step here, just cross multiply the 14 into tan 25. So x would equal 14 tan 25, which equals 6.53 meters. So if you want to know the height of the tree, then it is 9, which is the height of the house, which is here, plus the x, which is the 6.53, which gives me 15.53. So definitely this tree will hit the side of the house because it's this is 14, and if the tree is 15.53 meters long, when it falls, it's going to hit the side of the house right there. So that's the answer for that. So here's another question, and this question basically, if you read it, a surveyor needs to know the height of a cliff on the other side of a stream. So this is the stream basically. So this is the stream right here, and this is the cliff right there. So he want to know what's the height of this cliff right there. So he did some measurements, and he found out this, actually he put an assistant right across, and this distance between the surveyor and the assistant was 27. Also, he measured the angles between his vision and the assistant vision to the edge of the cliff to be 32 degrees. And then he measured the angle to from this line here to the top of the cliff, and it was 70 degrees. So what he wants to use this information to find out what's the height of the cliff. So again, this is indirect. We cannot really find the height of the cliff unless we work with this triangle first. So what do you need from this triangle? You have an angle right here. You have this length. Do we need to find this side? If you find this side, it doesn't help you. You cannot use it to find stuff on this triangle right here. But if you find the length of this side, then you will have enough information to work with this triangle to find the height right here. So what I want to find right now, I'm going to call this x right there. So I want to find x, and then we go and find the height of the cliff. So to find x in this right angle triangle right here, I have a 32 degrees right here. I have the side that's adjacent to 32, which is the 27. And x would be the hypotenuse because it's the longest side and it's opposite to the right angle. So adjacent and hypotenuse, it's right here. So that's Ka. So cosine, so if I go cosine of 32 degrees would equal the adjacent, which is 27, over x, what I'm looking for, which is the hypotenuse. Now, since the unknown is on the bottom, as I said, just cross exchange. So this the cos 32 crosses and goes where the x is, and the x crosses and go where the cos 32 is. So I'll have x equals 27 over cos 32, and that will equal 31.8 meters. Now, we know this is 31.8 meters. We want to find the height. So now we work with this triangle right here. So therefore, I'm looking for the height, which is right here. Now, if I look at the 70 degrees, opposite to the 70 is the height, and adjacent is the 31.8. So now we go back to tan again. So tan 70, because adjacent, opposite over adjacent is TOA. So tan 70 degrees would give you h, which is the height of the cliff that we're looking for, over 31.8. And therefore, this is just cross multiply the 31.8 into tan 70. So h would equal 31.8 times tan 70, which is 87.5. So the height would be 87.5, and that's C. So thanks for watching. Math is like a puzzle, and puzzles are fun to solve. Till next time, bye-bye.